In this video, we'll prove that cos x plus cos y whole square plus sin x minus sin y whole square is equal to 4 cos square of x plus y by 2. At first glance, this expression looks complicated because it contains both sine and cosine terms. But the trick is to expand everything carefully and then look for familiar identities. Let's begin by expanding both squares. We get cos square x plus cos square y plus 2 cos x cos y plus sin square x plus sin square y minus 2 sin x sin y. Now, instead of looking at every term separately, group similar terms together. We have cos square x plus sin square x, then cos square y plus sin square y, and finally 2 times cos x cos y minus sin x sin y. This grouping is important because the first two groups immediately remind us of the Pythagorean identity sin squared theta plus cos squared theta equals 1. Applying this identity, the expression becomes 1 plus 1 plus 2 times cos x cos y minus sin x sin y, which simplifies to 2 plus 2 times cos x cos y minus sin x sin y. Now focus only on the remaining part, cos x cos y minus sin x sin y. Does that look familiar? Yes, it is exactly the cosine addition formula. Cos of x plus y is equal to cos x cos y minus sin x sin y. Substituting this identity, the expression becomes 2 plus 2 cos of x plus y. Next, factor out 2 from both terms. This gives us 2 times 1 plus cos of x plus y. We are now just one identity away from the answer. Use the half angle identity. 1 plus cos theta equals 2 cos square theta by 2. Here theta is x plus y. So we get 2 multiplied by 2 cos square of x plus y by 2. Finally, multiplying the constants gives 4 cos square of x plus y by 2, which is exactly the right-hand side, hence proved. Notice the beautiful flow of this proof. We never performed any difficult manipulation. We simply expanded the squares, grouped the terms intelligently, recognized a standard trigonometric identity, and then finished with a half-angle identity. Once you know which identities to look for, the entire proof becomes straightforward. Now let's solve the next identity. We need to prove that cos x minus cos y whole square plus sin x minus sin y whole square is equal to 4 sin square of x minus y by 2. Just like the previous question, the first step is to expand both squares. Again, group the terms wisely. We have cos square x plus sin square x, then cos square y plus sin square y, and finally minus 2 times cos x cos y plus sin x sin y. The first two groups again simplify using the identity sin square theta plus cos square theta equals 1. Now observe the remaining expression carefully. Cos x cos y plus sin x sin y is nothing but the cosine difference formula. Cos of x minus y equals cos x cos y plus sin x sin y. Substituting this identity, we get 2 minus 2 cos of x minus y. Factor out 2. This becomes 2 times 1 minus cos of x minus y. Now apply another half angle identity. 1 minus cos theta equals 2 sin square theta by 2. Here theta is x minus y. Substituting it, we get 2 multiplied by 2 sin square of x minus y by 2. Simplifying gives 4 sin square of x minus y by 2, which is exactly the required result, hence proved. Compare both proofs carefully. The only real difference is the sign.